Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I teach online seminars for exams PFM, IFM, and LTAM, and you can purchase my study manuals for those exams as indicated. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. Let T1 and T2 represent the lifetimes in hours of two linked components in an electronic device. The joint density function for T1 and T2 is uniform over the region defined by T1 greater than or equal to 0, less than or equal to T2, less than or equal to L, where L is a positive constant. Determine the expected value of the sum of the squares of T1 and T2. And notice that all answers depend on the parameter L, but that's not unusual given that it's a parameter defining the area where the joint density is uniform and constant. Because when the joint density is constant, the distribution is uniform. Well, anyway, here is that region. So we want the region where both T1 and T2 are between 0 and L, but T2 is bigger than T1. And of course, along this diagonal line that you see, T1 is equal to T2, or T2 is equal to T1, and above the line T2 is bigger because T2 gets bigger as you go up. And of course, the region where the joint density is positive and is a constant is that triangle that you see there, indicated by dotted lines. And the expected value is a double integral of T1 squared plus T2 squared times the density, but only the integral is only taken over that triangle where the joint density is positive, although it's constant. And that's for T2 running from 0 to L, and then for T1 running from 0 to T2 because T2 is bigger than T1. Now we are told that the joint distribution is uniform over the triangular region, and therefore the joint density function is constant over that region, and it is equal, in the case of constant density in bivariate distribution, the joint density function is a constant that's always equal to 1 over the area of the region where that density is positive. In this case, it's a triangle which is half of a square. The square has the area of L squared, and half of it is 1/2 times L squared. So the joint density is 1 over half of L squared, which is the same as 2 over L squared. Therefore, the expected value is the integral from 0 to L of the integral from 0 to T2 of T1 plus T2 squared times 2 over L squared, and then the inside integral is with respect to T1 and the outside is with respect to T2. So we take the integral with respect to T1 first, and what do we get? We get 2 over L squared is a constant. We just put it out, and we have integral from 0 to L of the integral from 0 to T2 of T1 squared plus T2 squared dt1 in there. So we take the integral of that with respect to T1, and what do we get? 1/3 T1 cubed plus T1 T2 squared, because T2 squared is a constant with respect to T1, and we evaluated from 0 to T2, and what we get is integral from 0 to L of 4T2 cubed over 3 dt2, and of course that integral of this expression is the top expression, 4T2 cubed. The integral of that with respect to T2 is just T to the fourth. So we have T to the fourth over 3 evaluated from 0 to L. Of course, at 0, It's only the value at L that matters, which is L to the fourth over 3. And L to the fourth divided by L squared is L squared, and then 2/3 remains. So 2/3 L squared, which is answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.